everyone, this is a video tutorial to help you understand how to predict products for an E2 reaction when fluorine is your leaving group. So if we take a look at our alkyl halide here, we have a secondary. We know that secondary alkyl halides will do an E2 reaction. Once we've established our alpha carbon, we then establish our beta carbons. In this case, we have two beta carbons, and they are not equivalent to one another. This means that we have two potential constitutional isomers that will come out as potential products. So if the first carbon is the one that is used as the beta carbon, we'll form 1-butene. Alternatively, if it was this alternate beta carbon, we would form 2-butene. Now, normally you would go with the more stable alkene as being the major product. In this case, however, because the leaving group is fluorine, we're actually going to predict the major product to be our 1-butene group, or the less stable alkene. The reason for this can be understood if you take a look at the transition state. So in the transition state that we have, when this mechanism happens, you will develop a partial negative charge on this carbon right here. And this case here is a primary carbon. So what happens is the methoxide attacks the hydrogen. When this hydrogen is attacked by the methoxide, it releases its share of electrons between the hydrogen and its previous carbon bond. Now, normally what would happen is those electrons would then transition to exist as a double bond between the alpha and beta carbon. However, fluorine is a pretty stubborn leaving group, so it's not very easy to kick it off. So because it's a little bit slow to exit, these electrons cannot transition. So this carbon is sitting holding more electrons than it can bear easily. Because of that, it develops this negative charge. The exact same idea happens over here for the 2-butene. So now in this case here, when the attack happens, it's a secondary carbon that's bearing that negative charge. So now remember, there's an idea called hyperconjugation. Hyperconjugation is where adjacent methyl groups will donate electrons to carbons next to them. So this carbon has two other carbons donating electrons to it. It already has a negative charge, so it would be very destabilizing to have more electrons put on an area where you're already having a negative charge. In the case over here, this carbon only has one other methyl group next to it where it could have donation happen. So this has less areas of donation happening, meaning that it's more stable. So when we're talking about carb anion stability, tertiary is less stable than secondary, which is less stable than primary. So remember, in a case where you're looking at an E2 reaction where you have fluorine as your leaving group, you're going to predict the less stable alkene as your major product because of the carb anion that is formed during the transition state.